In this video, you will learn about tangent lines and circles. In Chapter 8, we studied the tangent ratio in triangles. The tangents that we will be concerned with in this chapter are related to circles. The tangent to a circle is a line on the plane of a circle that intersects the circle in exactly one point. And that point where the circle and tangent intersect is what is called the point of tangency. So if we look at the diagram below, the point of tangency is this point B. So if we were to write it in words, we could say that line AB is tangent to the circle and B is the point of tangency. And you could also say that ray BA and segment BA are also tangents to the circle because if you were to extend them into a line, they would only ever intersect the circle once. Now the first theorem we have about tangents says that if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So we could say that in this case, AB, or line AB, is perpendicular to segment OB, which means that we have two right angles as shown. Now in the diagram below, it says that ML and MN are tangent to a circle O, find the value of X. Now because we know that the lines are tangent, that means that we have where ML and the radius intersect is a right angle, and where MN and the radius intersect is a right angle. Now, if we look at the figure we have to the right, it's a quadrilateral. And when we have a quadrilateral, we always know that all angles add to equal 360 degrees. So I could use that information to write an equation. So I could say 117 plus 90 plus x plus 90 should equal 360. So if I simplify and I add the 117 plus 90 would give us x plus 297 equals 360. And when you solve, doing 360 minus 297 gives you that the value of x equals 63. So the answer for this question is B. Now the next example says that BA is tangent to circle C at point A, find the value of x. So if we know that this line is a tangent, that means that this is a right angle. Now we know that because it's a triangle, all angles in a triangle add to equal 180 degrees. So now if I write my equation, say 90 plus 22 plus x should equal 180. If I simplify that, the 90 plus 22 gives me 112. So 112 plus x equals 180. And if you finish solving, subtracting 112 from both sides, you get that x is equal to 68 degrees. Now the next theorem is a converse. So remember that a converse, from when we talked about it at the beginning of the year, is where you flip the statement. So it says theorem 12.2 is the converse of 12.1. It's used to prove that a line or a segment is tangent to a circle. You can also use it to construct a tangent to a circle. So this theorem says that if a line in a plane of a circle is perpendicular to the radius at the endpoint of the circle, then the line is tangent to the circle. So we can conclude that since there's a right angle, that AB would be tangent to the circle. So essentially what it's saying is that if a line is perpendicular to the radius, then it's a tangent. Now in this example, it says that we have a circle with the radius of 5. Point P is outside the circle, such that PO equals 12, and point A is on circle O, such that PA equals 13. Is PA tangent to the circle O at A? Now we want to figure out if it's tangent. We know that in order for it to be tangent, this has to be a right angle, but that's what we don't know. Now normally, in order to determine or to solve for a missing side in a right triangle, we use Pythagorean theorem. So a squared plus b squared equals c squared, or we have something like this where c is our hypotenuse and a and b are the legs. So in order to determine this, we're going to check if a squared plus b squared equals c squared. If it's equal, then it is tangent. If it's not equal, then it is not tangent. So in this case, we have, if I use, we know that 12 is going to have to be my value of c. So I have 5 squared plus 13 squared. We're checking to see if it's equal to 12 squared. If I plug in my 5 squared plus 13 squared, this gives us 194, and 12 squared equals 144, which is not true. So since these are not equal, this line is not tangent. In the next problem, it says, assume the segments that appear to be tangent are tangent, round to the nearest tenth if necessary. So since we're assuming this is a tangent, we can assume that this is a right angle. So if I use Pythagorean theorem, so I have a squared plus b squared equals c squared, because I'm solving for the missing side of a right triangle. So my value of c is going to have to be the value of x. So I can plug in, it would be 24 squared plus 10 squared equals x squared. If I simplify, the 24 squared plus 10 squared gives you 676 equals x squared. And to get rid of the squared, I'm going to square root both sides. So the square root of 676 gives us a value of 26 is equal to x. Now in this next problem, it says find x, assume that the segments that appear to be tangent are tangent, and round to the nearest tenth if necessary. So if we're assuming that this is a tangent, we can assume that this is a right angle. So we're going to have to use Pythagorean theorem. However, we don't know what this missing side is. We know we have x, but we somehow have to figure out what this is from the diagram. However, looking at the diagram, we can see that we have this length that I just highlighted in red. This is representative of the radius, which equals 3. Now, if the radius equals 3 in that part of the circle, that means all of the radius in the circle should equal 3. Now, the side we don't know, BC, is also a radius, so that side should also equal 3. Now, if I want to use Pythagorean theorem, my side lengths, I have a side of 3, a side of x, and this whole side is going to be those two sides added together. So it'll be 3 plus 7, which gives us a value of 10. And this is our value of c. So using Pythagorean theorem, where it's a squared plus b squared equals c squared, you have 3 squared plus x squared equals 10 squared. 3 squared gives us 9, plus x squared equals, and 10 squared is 100. Subtract 9 from both sides, you get x squared equals 91. And then you take the square root of both sides, so you get x equals, and the square root of 91 is a decimal, so we're just going to round to the nearest tenth, which means 1 decimal place. So it would be 9.5. Now in our next example, we have all the given side lengths. I can assume that this is a right angle. Now the one thing we need is, in order to use Pythagorean theorem, I need this whole side length. Now to find the length of the whole side, I would just add them together, so it becomes x plus 8. Now in the previous example, we could add the two numbers to get a final number. We can't here, which means we're probably going to end up having to FOIL to solve. So if I use Pythagorean theorem, and I plug in, I have an x squared plus 12 squared equals the value of c again is straight across, so it'll be the whole value of x plus 8 squared. Now x squared is going to stay as x squared, 12 squared becomes 144, and x plus 8 squared is really x plus 8 times x plus 8. Now, if I were to simplify x plus 8 times x plus 8, we're going to have to use FOIL. So when we do that, the x squared plus 144 is going to stay the same. When I FOIL, we multiply the x times the x, gives us x squared. The x times the 8x, or times the 8, gives us plus 8x. And now we're going to have to do the same thing to distribute with the 8 in the second half of the parentheses. So you can multiply the 8 times x, so it's plus 8x, and the 8 times the 8, so it's plus 64. Now if you simplify that, the x squared plus 144 stays the same. On the right, I can combine the two 8x's. So it gives us x squared plus 16x plus 64. Now, if we want to solve, we first want to bring all the x's to one side. So if I try to move the x squared so they're all on one side, I would have to subtract x squared from both sides. However, notice that those x squareds end up canceling out of both sides. So it becomes 144 equals 16x plus 64. And now the x squared is gone, so it's a problem we're typically used to solving. So if I subtract the 64 from both sides, it gives us 80 equals 16x, and divide both sides by 16, it gives you 5 is equal to x as your final answer. Now the next theorem we have says that two segments tangent to a circle from a point outside the circle are congruent. So because these two lines are tangent, we can assume that those two segments are congruent. So in this type of problem, we are solving for x and assuming the segments are tangent. Now because there are two tangents that meet outside the circle, we can assume they're congruent. So I can set them equal. So x plus 15 equals 2x minus 5. So if I solve, I can bring all my numbers to the right. So I get x plus 20 equals 2x, and then subtract x from both sides to bring all the x's to the right. So I have 20 equals x as your final answer. Now the last type of problem we have to deal with deals with multiple tangents. So it says if a circle is circumscribed about a triangle, then the triangle is inscribed in the circle. Similarly, when a circle is inscribed in a triangle, as shown below, the triangle is circumscribed about the circle. So each side of the triangle is a tangent to the circle, because looking at the diagram, we can see that at each point, these lines are only intersecting the circle once, making them a tangent. And we know that based on what we know with tangents, that the points outside the circle are congruent. So this part is congruent to this. This part over here is congruent to the other part. And this part down here is congruent to the other part. Now, in order to solve a problem like this, we have to work our way around the figure using what we know, because it asks for the perimeter as our final answer. So we know that the RX piece is congruent to the XU piece. So they're congruent, so that means this side is 11. For the next part, we have that TW and UW should be congruent. So since TW is 7, UW is 7. Then we have that since ZT and SZ are tangents that meet outside the circle, they should be congruent. So since ZT is 6, SZ is also 6. And then lastly, since RY and YS are tangents that meet outside the circle, they should be congruent. So since RY is 8, YS has to be 8. Now to find the perimeter, we're just going to add up all the side lengths. So the perimeter equals, I have 11 plus 8 plus 8 plus 6 plus 6 plus 7 plus 7 plus 11. And when I simplify that, combining all the numbers, it gives us a value of 64. So your perimeter is 64 feet. In the last example, it's given to us that the perimeter is equal to 88 centimeters. Now, based off of what we know, we have that since PX and PZ are tangents that meet outside the circle, they're congruent. So since PX is 15, PZ is also 15. For the next part, since ZR and YR are tangents that meet outside the circle, they're congruent. So since ZR is 17, I'm going to call YR 17. And lastly, we have XQ and QY that meet outside the circle, so they're tangents that are congruent. However, we don't know what the length of them are, so we're going to call them both X. Now if I want to use my perimeter, we know that the perimeter of 88 should equal the sum of all the sides. So you have 15 plus X plus X plus 17 plus 17 plus 15. And now if I simplify, it gives us that 88 should equal 2x plus 64. So if we solve, we can subtract 64 from both sides, which gives us the value of 24. And then divide both sides by 2. So you get 12 equals x, which means that both of these side lengths are 12. So this gives us that QY equals 12.